Hey everyone, this is a quick follow-up to last week's video on solar analytics. So at the end of the video, I showed that one limitation with the Python-based method I'd gone with was it was very slow to compute. So I put the call out to see if anyone had some ideas how to make it run faster. And one person responded. A huge thank you to Gavin Crump, aka the Aussie BIM Guru. He's been a big supporter of helping me set up this channel. And at the time of recording this, he's about to get married tomorrow. Anyway, he put me onto one of his videos on the same topic, where he had a node-based workflow that showed how if you rebuild the BREP into a gridded mesh first before joining it, you could run it through Ladybug much faster as a single mesh, and then just split the result at the face count of the meshes. So anyway, I tried to recreate what he did. I didn't put it into a cluster. But here it is, roughly the same sort of process as a node-based workflow. When it gets to here, for some reason it only seemed to grid this one. And with some of the other ones, like this one, had this error, mesh has no attribute to BREP. I'm not really sure what that's about and why it didn't work, but anyway, I kind of gave up at that point and thought, alright, well, I prefer to just code stuff, so I'm going to make another custom component. So one of the things that I wasn't quite satisfied when I sort of got it working was that the edges of the grid generated didn't quite line up with the original border. So when I built mine, I integrated some logic which got around that. So introducing the high fidelity gridded BREPs from MeshNode. So it takes the BREPs and there's some C# in there and it outputs all of those rebuilt as though they had a 500 grid. So if we turn that off, you should be able to see it. If we were to bake this out, put it on the default layer or whatever, what you'll see is that near the edges, where the grids come like that, then it gets chopped, and the bit that is still within the boundary gets kept as a slightly smaller tile. Alright, so after it's passed through Fidel Castro here, it comes up and then it feeds in to the Ladybug as before. It feeds the joined mesh, and that mesh is still joined at this point. And now I have another one which gets the results, which are coming through as one single flat list. And the meshes tree, which came out of here, and it knows that each of those meshes has a number of faces. First one has 90 faces, so all the scores between 0 and 89 will be related to that mesh. From there, the results tree can just feed through into this one as normal, as we had before. And the meshes can come through from this one, and straight away, 253 milliseconds, we've got all that analysis done. Alright, so I think I'll be sending that to Gavin as a bit of a little wedding present. We managed to take what took in the hacked Ladybug Python something like 35 minutes. We got that bit down to 12 seconds, and then the process of regridding the mesh, well, that took 32 seconds, so it's like half an hour down to like a minute. So all of that took me just a couple more hours work to build those custom components in C#. Totally worth it. Gavin got back to me on the Thursday, put the work in on the Friday, and the thing is that on Saturday I was going away to the bush for a meditation retreat, and the last thing I wanted to be thinking about while sitting on a cushion trying to focus on my breath was that. But I got it done. Took me a while to make the video. Once I got back, here it is. Happy wedding, Gavin.